Okay, let's continue this little 3D project for the Playdate. And this is what we have so far from the last video, just a bunch of test stuff. We're gonna remove that because now we're gonna work on the 3D rendering. Like discussed in the first video. I have to remove the logo, remove this. We don't need any of this anymore. Also don't need the drawFPS. This also don't need, probably, yeah, we don't even need an init method right now. Okay, so everything now is pretty clean. This is a good foundation to start with. So again, the formula that we want to use is this. It takes a 3D point and projects it onto a 2D screen. This is the formula. So yeah, first we gonna just print or create some points onto the screen. And we do that by graphics, draw. There is no point, I guess. So we need to use drawRect, which should be okay for us. Wait, drawRect. Origin. I like this version more. drawRect. Okay, then let's make this as a draw point because that's what we basically need, right? So we'll just use the same here, float, y, float, and that's it, because we're just gonna hard code the size of it. And I guess drawRect. Now we wanted to have this version. This is just x, this is just y, and then the width here is maybe 2, and the height is also 2. Float, float, float. What's the problem? We need to wrap this in a rect. This is the issue. Perfect. Quickly format this, replace this, and I'll show it on screen. And important is, for the formula to work correctly, we need to, the 0 point has to be in the middle. So instead of here where 0 is here, and then this is the the y-axis, and this is the x-axis, it needs to be like this. The 0 needs to be here, and then y1 needs to be here, and x1 has to be here. So let's try this out first. So we're gonna draw a point in the 0, and let's see where it will end up. Here. Okay, so this is wrong, which means we're gonna need a function to turn the coordinate from the Playdate coordinate system into our new coordinate system. And I'm just gonna call this screen, and it will accept a point and will, yeah, give us a point back, because we just have to change this. So we do this, and the formula is pretty simple. We take the point x plus 1 and then divide it by 2 times the screen size. The screen size should be here. Display, no. Display, there it is, okay. Display width, perfect. What's the problem? Oh, it's an int. That is not a problem, is it? We can just change this to a float, I think. Cool. Same thing for y, plus 1 divided by 2 times display height. Okay. I just noticed it would probably be better if this would also accept the point. And then here I think we can just, no, origin, oh, perfect. Great, this is great. So then we're just gonna use start to use points, which is fine. So again, 0, 0. But we need to wrap this in screen. Okay, this seems to work. Do I need to have this stay around here, do this every time? Seems like it. Okay, perfect. It's here. Now give this a quick test. So one more point at 0.5, which would be up, and one more point at x.5, which should be on the right side. So you can see it is the point is moving correctly now. Okay, so the y-axis didn't correctly work. Let's see why that is. So it's here. So basically you just need to flip it around, which we can do by subtracting 1. Wait, what? Right, I made a mistake. This is not here, but here. Perfect. Okay, now the projection is working correctly, which is good. Now we need to add a new function called project, which takes a 3D point. So now we can maybe use x float, y float, z float, and we gonna return a point. And this is the formula that I was showing at the beginning. It's very simple. It's just x divided by z and y divided by z. Great. And whoops. So this is project. Yeah, let's project something. So draw point. We're just gonna make 4 points, so it looks like a square on the screen, which is gonna be just like a plane basically. Yeah, so we need to project our point. Let's say 0.5, 0.5, and then 1. Drop another. Oh wait, this is not enough, of course. We still need to wrap this in screen because we need to convert it to our screen coordinates. Let's do this for this 4 times. So it's going to look like this and this, and we can remove the old points. So this should be look like a square. Perfect. It doesn't really look like a square because our screen is not a perfect square. It is this format, but this should be fine for now. Cool. Let's animate this so we can see how this works. We have system here, and I think elapsed. Do we have elapsed time? Oh, elapsed time. That is perfect. So let's take this and just move z. So we have a z here. Z starts with 1, and then once we start it, z. Oops, is that the right syntax? This one, right? We increase z by system elapsed time, and then but maybe through 1000, so it's a little bit slower. And then let's just replace this and always use this z variable. So it's still all on the same plane, if you think about it. But it should be now moving to the back because we give it distance. Okay, it's very slow, and I totally forgot to clear the screen, but it is Yeah, I think this is way too slow. Do we need this 1000? Let's make it 100. Okay. Graphics, clear. Perfect. Okay, this should work. We need to clear the screen each time when we draw something new. Oh. This was not intended. Need to clear this wide again. Hope this works. Perfect. Okay, you can see the plane and we move it back so it gets smaller. So that's already working. If you think about it, yeah, we just take the points on here, and then we just use the 3D projection to increase that, which means it goes more into the scene until it's a tiny point, because when objects move far away, they just come closer together, get tinier, and you can see they all go to this point here in the middle. And yeah, let's just leave it here. Tomorrow I'm gonna make a little cube, I think, and make it rotate using the crank. But this is all for today.